Hi everyone, Ricardo here again. So now I'm going to kind of show you how to take a file and slice it with Repetier host and prepare it for your BioBot. So you can get anatomical files from a lot of different places, and so some of the best places that I found is this lifesciencedb.jpg/bp3d/, and so it's really good, or at least used to be. They seem to have taken down a lot of files. It's Japanese, but nonetheless their STLs are really some of the best that I've ever seen. There's another one called 3dprint.nih.gov, which is kind of gaining traction, and they have different files. There's Thingiverse, which also has some interesting files, and I'll be posting some of our own designs on the Google group that we've been able to have success with, things like a nose or an aortic valve, or other things that, more simple things like a ring. A lot of people, find interesting structures in a ring, and the rings, I've actually designed in SolidWorks. So SolidWorks, Autodesk, another great CAD tool is called Blender, and Blender is really good for morphing objects, and just not necessarily great for designing really precise objects, but if you have, like, let's say an MRI that you've got from somewhere, like maybe a kidney. So import, let me see if I can find import STL document kidney. So here you have a kidney, somewhat of a kidney-shaped form, but it's really easy to manipulate this or cut it in half when you learn how to use Blender versus SolidWorks. But in SolidWorks, it's really great to be able to design kind of more precise rings and structures and know their heights and things of that nature. So we'll start with this ring. So we'll go back to our Repetier host software, and so I have it named as part 1, I think, right now. Yeah, part 1. Sometimes I call it by pediatric bronchi, but for now it's part 1. And so when we're setting up our object, it's really important always to take your object and set it in the corner right here, because your BioBot doesn't know its actual printing boundaries, like how large your printing bed can be, so it can run off and hit kind of the wall, because it doesn't have a limit switch on this side. It only has a limit switch on this side, so it only knows its 0 point and it doesn't really know its max. So a good safety rule is to always just take your design and put it in the corner. So then so again, this is a 3D, meant for 3D plastic printing, and so we're just going to take this and kind of reconfigure it a little bit for bioprinting settings. And so Slicer is like an engine. It's like basically a tool that takes your STL file, which is a complete solid, and goes and makes commands for the printer to be used layer by layer. And so we'll start here. So layer height, that's basically how much distance you want in between each layer, and we'll start with 0.2 for both of these. So perimeters, that's more of like how I guess you could say, if you have a solid structure, how many times do you want that outer structure to be passed through? And you'll see that if you play around with it, you'll see the differences, but for a real good purpose, it's just 1, and probably this is best at 0. Solid shells. The infill, so this is something you can also play around with, but fill density, you're going to want it at 99 just to start off with, and that's just because most structures you just want to print solid, and playing around with fill patterns, especially in bioprinting, is should be very interesting. But I think the simple way to start is just having a full 99% fill density. So another thing we'll have to do is we'll have to slow the printer down as compared to plastic printers. So printing at 4 millimeters per second is actually a good speed to be able to get nice extrusion, at least with the materials that we're using. So I think the upper limit of this printer, because it's designed for bioprinting, is about 200 millimeters per second. So you don't really want to be going much faster than that. And nonetheless, I think for most bioprinting applications, doing things like really slow is going to be key to get nice resolution. First layer, we can also put that at 4 millimeters per second. No percentages. Skirt, you want to take these out, put 0 loops, 0 skirt height. Support material, those shouldn't be checked, and we don't have to touch those either. And so we can save that. We can go to save this little scan this thing here, save and say OK. Then we'll go to filament settings. So super important, we have to change these temperatures to 0 and 0. If not, the BioBot will get confused. We'll also enable auto cooling off, and we'll go ahead and save that preset. Then we'll go to printer settings, and what's important here is to be able to play around with the nozzle diameter. So we're going to put 0.25, because if I'm not mistaken, part 1, this cylinder has an outer ring of 250 microns. So nozzle diameter is something that you can play around with, and a good way to just gauge it, or to kind of predict what it should be, is by using the gauge that you're using on the syringe. So we're going to be using a gauge that has an inner diameter of 250 microns. So I also designed the print to have a 250 micron thickness. So the idea there is that when we slice it, it will only have one layer going in circles. So we'll go ahead and save that as well, and then you're ready for slicing. So we go ahead and we say slice, and so now we can see kind of it's sliced, and you can see the different layers here. And so the dark blue lines represent the movement, the printer movement of extrusion, and this kind of bright blue light represents the movement of the printer while it's not extruding. So now you're ready for printing, and we'll go ahead and do that in the next video.